All right, let's jump right in. Welcome to today's Explainer, where we're going to explore a topic that is absolutely essential for anyone looking to take their reef health and coral vibrancy to that next level. We're looking far beyond the basics today to really understand the microscopic chemistry of your aquarium. Our source material for this deep dive breaks down exactly why trace elements matter and how unlocking this hidden world is literally the key to a thriving, rock-solid saltwater ecosystem. Look, to start, we have to talk about an incredibly frustrating experience that I'd bet almost every dedicated reef aquarist faces at some point. You test your water, you do your weekly maintenance, and your basic parameters are absolutely perfect. But despite doing everything right, you hit a wall. Your stony corals start to lose those vibrant colors, their growth just slows down to a crawl, or worse, you start seeing completely unexplained tissue loss. So why does this actually happen? Well, the answer lies in what we aren't seeing. Now, you know the drill. Every aquarist learns early on to obsess over what we call the big three. And honestly, rightly so. Calcium, alkalinity, and magnesium, they're the heavy hitters. They form the fundamental chemical backbone of any saltwater ecosystem. They support your coral's skeletal growth and provide overall stability to the water. But the crucial point here is that as your stony corals grow and their biological demand ramps up, focusing exclusively on these basic parameters just isn't enough anymore. I mean, they are essential, sure, but they simply aren't the whole story. To understand why, we have to dramatically shift our scale. We're stepping away from our familiar macro elements and zooming way in to reveal a hidden, microscopic world of over 45 major, minor, and trace elements. We are talking about chemistry happening at the level of parts per billion. Think of it like measuring the concrete foundation of a house versus inspecting the tiny, microscopic screws holding the entire structure together. When your corals are fading despite having good macro parameters, it's almost always because something in this massive list of trace elements is out of whack. So how in the world do we measure something so unbelievably small? Well, that brings us to ICP-OES. It stands for Inductively Coupled Plasma Optical Emission Spectroscopy. And yeah, I know the name is a total mouthful, but what it does is wonderfully straightforward. It tests your water down to parts per billion. Introducing ICP testing into your routine is the definitive, go-to solution that completely removes the guesswork from advanced reef chemistry. But how exactly does a laboratory achieve this crazy level of precision? Okay, the science here is just wild. 8,000 degrees Celsius. When you send your aquarium water sample to a lab for an ICP test, it gets injected into an ultra-hot plasma flame that exceeds 8,000 degrees. In this absolutely extreme environment, every single element within your water sample gets energized and emits a unique wavelength of light. The laboratory's instrument then reads the intensity of these specific light signatures to determine exactly how much of each element is floating around in there. Which leads us to a massive upgrade in how we manage our tanks. Home titration kits rely on color matching, right? Which means they're entirely subject to human visual bias. I mean, have you ever stared at a tiny glass vial, holding it up to the light, wondering if the liquid is light pink or maybe medium pink? We have all been there. Laboratory spectrometers, however, read high-precision light signatures. They completely eliminate that human error, and even more importantly, they detect incredibly precise chemical changes long before your sensitive corals are ever actually harmed. Section 1. The biological triggers, vital trace elements. So while these trace elements are microscopic, they act as absolutely vital biological triggers for corals, macroalgae, and your beneficial microbes. And a deficiency in any one of them causes highly specific physical symptoms. Without them, the biological engine of your reef just stalls out. First up, iodine. You're targeting around 60 to 90 micrograms per liter, and it supports soft tissue defense and UV protection. So if you're seeing dull purple or blue tones, or you notice crustaceans struggling to molt, iodine might be missing. Next is iron, which is crucial for photosynthetic enzyme production. If your Chaopomorpha is lagging or your green corals are looking pale, definitely check your iron. Then we have potassium, targeted around 390 to 410 milligrams per liter. This one is fascinating. It actually synthesizes red pigments. So if your red and pink corals are suddenly fading to gray or the branches are getting brittle, potassium deficiency is for sure a prime suspect. Then there's molybdenum, vital for nitrogen assimilation. Without it, you'll see really slow tissue expansion and poor polyp extension. And finally, strontium, which reinforces the skeletal lattice right alongside calcium. If your coral skeletons are looking thin and brittle, they probably need a strontium boost. Every single part per billion serves a critical purpose here. Section 2. The hidden killers, uncovering toxins. Now, there's another side to ICP testing, because the greatest benefit of laboratory precision isn't just seeing what's missing from your water, it's actually discovering what's secretly accumulating. Turns out, everyday aquarium equipment can slowly betray you. Copper is highly lethal to invertebrates, even at single-digit parts per billion, and it often sneaks in through a faulty RODI unit or just a bad batch of salt. Then you have tin and zinc. These frequently leach into the water from equipment that's degrading right under your nose. We're talking corroded pump impellers, rusting magnet mounts on your glass, or degrading light fixtures. Because they break down so slowly, these lethal toxins accumulate silently over time, completely escaping the notice of standard test kits until, well, a catastrophic crash happens. And here's one of the most shocking hidden sources of contamination: aluminum. You might actually be intentionally introducing it without even realizing it. Aluminum is often brought into the system by really common filter media, like high-phos media or ceramic filter blocks. And as it builds up, it causes closed polyps and devastating tissue necrosis, particularly in highly sensitive SPS corals like Acropora. The scariest part, by the time you actually notice that tissue necrosis, the aluminum buildup is already severe. ICP testing flags this subtle buildup long before it ever reaches that toxic threshold. Section 3. The Action Plan: Proactive Reef Management. So what do we actually do with all this advanced data? Well, by integrating ICP data, we can move away from reactive troubleshooting and shift toward proactive management. Here are 3 sequential rules for safely handling this data, straight from our source material. Step 1, test continuously. Send out an ICP analysis every 3 to 6 months. This lets you spot those gradual chemistry drifts before they become severe problems. Step 2, avoid knee-jerk corrections. This is huge. If an element comes back slightly out of range, you absolutely must resist the urge to correct it all in a single day. That will shock your ecosystem. Make your target adjustments slowly over 1 to 2 weeks. And step 3, cross-check your home kits. You can use the highly accurate lab-confirmed calcium, magnesium, and salinity metrics from your ICP test to calibrate and double-check the accuracy of your daily home testing kits. That way, you know your day-to-day readings are actually trustworthy. By stepping beyond those big 3 macro elements and utilizing the power of a laboratory spectrometer, you give your ecosystem exactly what it needs to thrive, while catching those silent killers before they ever strike. This explainer has really shown us that ensuring long-term stability and vibrant coral coloration requires looking much, much closer than we ever have before. Which leaves us with one final and honestly very important question to consider about your own aquarium. Are you ready to see what is really hiding in your reef water?